And does anybody remember when we're given a diagram and we have 2 points, how we can, by using the graph, find the slope of the line? We count something over something else. Does anybody remember what that is? Leilani? That's exactly what it is. We count the rise over the run. Now, for me personally, I always start left and work my way right, but ultimately it doesn't matter. So if I want to find the slope of this line AB, I'm going to start at A and I'm going to work towards B and I'm going to find my rise over my run. So now my rise is not going up. My rise is going down 1, 2, 3. Since it's not going up and it's going down, that's going to be a -3. And then, so I'm rising -3, meaning I'm going down 3. And then I'm running to the right 1, 2. So to the right is where all the positive numbers are. To the left is where the negative numbers are. So if you run to the right, that's positive. If you run to the left, that's negative. So my rise over my run is -3/2. And you always write a slope as a fraction. And just like with all other fractions, if you can reduce the fraction, should you reduce the fraction? Yeah, but -3/2 can't be reduced, so I leave it just like that. We don't change it to a decimal, we don't change it to a mixed number, we leave it as an improper fraction. Now, you might ask me, well, what if I started at B and I moved towards A? That's okay. If you started at B and you moved towards A, instead of going down 3, you would have gone up 3 for a +3, but then you would have moved left 2. And remember, left is negative, right is positive. So even if you moved from B to A, you still would have ended up with a -3/2. It doesn't matter where that negative is, whether it's in the numerator or the denominator. It doesn't matter. Okay, next one. So I want to find the slope of A to B. So I'm going to start at A and I'm going to work towards B. So this time I'm rising up 1, 2. So that's a +2. And then I'm running to the right 1, 2, 3, 4. +4. So now my slope should be my rise, which is a +2, over my run, which is 4. But can I simplify 2 over 4? Yeah, I can divide top and bottom by 2. So that gives me a slope of a half, 1 over 2. All right, I want you guys all to try letter C. Jay, why are you sideways? What's going on? Why are you sideways? Okay, so for letter C, I'm moving from B to A and I'm rising 1, 2, 3. So I'm going up 3, that's a +3. And then I'm running to the right 1, 2, 3, 4, 5, 6. So my rise over my run is 3 over 6, which simplifies down to what? A half again. So we divide top and bottom by 3 and we end up with 1 over 2. How many people got that? Okay, so you guys do D, E, and F by yourself. Yes. Sure. Okay, let's go over these. So for this one, for letter D, I'm starting at this point and I'm working towards this point. So this time we're going to go down 1, 2, 3, 4, 5, 6, 7. So since we're going down 7, that's a negative 7. And then we're going to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. And since we're moving to the right, that's a positive 9. So my slope is my rise, which is negative 7, over my run, which is 9. All right, letter E. Again, I'm working from this point to this point. So this time I'm going down 1, 2, 3, 4. Since we're moving down 4, that's a negative 4. And then we're moving to the right 1, 2, 3, 4, 5. That's a positive 5. So this slope is negative 4 over 5. And the last one, I'll start here and I'll work my way to this point. So we're going up 1, 2. So that's a positive 2 since I'm going up 2. And then I'm going to the right 1, 2, 3, 4, 5, which is a positive 5 to the right. So this is 2 over 5. For all of these slopes, I can't reduce the fraction, so I just leave it as it is. So now what I want us to do is the way we read a graph, the way we always read a graph is from left to right. Just like we read in English, right? When we take a book and we read in English, we read left to right. Well, we read a graph left to right. So do we agree that in D, from left to right, that line is going down? In E, from left to right, that line is going down. But in F, from left to right, that line is going up. So this means the line is decreasing, the line is decreasing, the line is increasing. So decreasing means it goes down, increasing means it goes up from left to right. Well, do you notice something in common between the two lines that are decreasing versus the line that is increasing? About their slopes, I should say. Do you notice something that the two lines that are decreasing have in common? They're both negative. That's not a coincidence. When you have a negative slope, your line will always be going down. When you have a positive slope, your line will always be going up. All right, so which lines above are increasing? What do you notice about their slopes? So we're going to say D and E. Oh, sorry, not D and E. We'll just take the last two. We'll say F is increasing. The slope is positive. Which lines are decreasing? We're going to say D and E are decreasing. The slopes are negative. Is anybody still copying this? Okay. Now, sometimes we're not given the diagrams. Sometimes we're just given 2 points. So if we're just given 2 points, their coordinates, how would I find the slope? It's going to be another formula. It's going to be y2 minus y1 over x2 minus x1. Okay, so find the slope of each line containing the following points. Do you guys remember when you have a point, it's an x coordinate and a y coordinate? So the first point I will call x1, y1. And the second point I'm going to call x2, y2. And to find the slope, what you do is you take y2 and subtract y1 from it, and then x2 and subtract x1 from it. So now let's plug in. What number goes with y1? I'm sorry, y2. What number goes with y2? Stella? Yeah, -3 goes with y2. So this is going to be -3 minus y1. Do we all agree that 9 goes with y1? So it's going to be a -3 minus 9 in our numerator. And then in our denominator, we have x2. Do we agree 8 goes with x2? 8 minus x1. And 5 goes with x1. Any questions with why I have those numbers in the spots I put them? Okay, in my numerator, I have -3 minus 9. I always say do your keep, change, change, -3 minus 9, keep, change, change gives us a -3 plus a -9, which is -12. And then 8 minus 5 we know is 3. Can I simplify -12 over 3? We sure can. -12 divided by 3 is a -4. If you wanted to put -4 over 1, you could, but you don't have to. You could just leave it that the slope is -4. Okay, I want you guys to try letter B on your own. Okay, so I'm going to go ahead. I'm going to call this x1. I'm going to call this y1. I'm going to call this x2. I'm going to call this y2. And now we know the slope is going to be y2 minus y1 over x2 minus x1. So now we're going to have the y2, which is 14, minus the y1, which is 10. And then in our denominator, we have the x2, which is 8, minus the x1. Now, that's not just going to be 8 minus 8. That's going to be 8 minus a -8. And now we simplify. 14 minus 10 is 4. When you have 8 minus a -8, doesn't that double negative make a positive? So it's 8 plus 8, which is 16. So 4 over 16 is good, but it's not the answer that will get you full credit. Why is this not the answer that will get you full credit? we can reduce it. So we're going to divide top and bottom by 4, and we're going to end up with 1/4. Okay, so now it's saying plot these 2 points. So we're going to plot the point -4, 3. Now, if you guys remember from the middle school, when you plot a point, the point is represented x comma y, meaning you go x and then you go y. So we're going to go on the x-axis. Remember, the x-axis is the horizontal axis. The y-axis is the vertical axis. So it's saying go -4 on the x. So here's 0. So -4 is to the left. 1, 2, 3, 4. But then go up 3. 1, 2, 3. I'm going to call this point A. Now we want to plot the point 5, 3. Again, x comma y. So you start at 0 and you go 5 on the x. 1, 2, 3, 4, 5. But then up 3 on the y. 1, 2, 3. And then we're going to connect those 2 points with a segment. Does anybody know what this line is called that's perfectly straight across like this? Starts with an H. What kind of line that is? Horizontal. Good. This is a horizontal line. Now, if I'm going to find the slope, it's rise over run. So now to get from A to B, am I rising up or down at all to get from A to B? No. So if I'm not going up or down at all, do we agree that's a 0 for my rise? And now my run is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. My run is 9. What's 0 divided by any number? 0. This is not a coincidence, right? Anytime you have a horizontal line, it's always going to have a 0 slope. Anytime you have a horizontal line, it's going to have a 0 slope. And I always like to relate slope to skiing, right? If you were skiing on this line, would it be fun? It wouldn't be fun because there's 0 slope there. There's nothing that will pick up. But will you be safe? Yeah, you will be safe, but won't you be dragging yourself the whole time, right? There's no speed because the slope is 0. So anytime you're skiing on a horizontal line, that is a 0 slope. Okay, let's talk about the other special case. Let's plot these points. Actually, I want you guys to plot the point 5, 2, and then 5, -4, and then just turn over your computer and hold it up for me because we have to make sure we plot points properly. Perfect. Perfect. If you need help, if you forgot how to plot points, just let me know. With plot chat. You're just on the line here. Yep. Good job. Good job. Good job. See. So, okay, so what should this have looked like? We're walking over to +5 and then up 2. And then we're walking over to +5, but then down 4. So we're looking at this line right over here. Call this C and D. So now this is, what do we call a line that's up and down? So left, right line is horizontal line. Starts with a V, up, down. Vertical, perfect. This is a vertical line. So now if we're going to find the slope of this vertical line, it's our rise over our run. So we are going to rise. Doesn't matter if you go from C to D, you're going to go down 1, 2, 3, 4, 5, 6. So you're going down 6. Am I running left or right at all? No, so that's a 0. Does anybody remember? Are we allowed to ever have a 0 in the denominator? No. If you type in your calculator a number divided by 0, it comes up an error. It's undefined. This isn't something we're allowed to do. We're never allowed to have a 0 in the denominator. So never allowed to have 0 in denominator. So for this, when you have a 0 in the denominator, the slope is going to be undefined. Because the fraction's undefined, the slope is undefined. And this is not a coincidence. Every vertical line will have an undefined slope. So in the horizontal line, you're safe, you're alive, you're just having 0 fun, right? But if you were to ski down this vertical line, would you survive this? No, if you were to ski down this vertical line, you would die. It's an undefined slope. There's no chance for survival. Okay, so let's sum this up. The slope of a horizontal line is 0. The slope of a vertical line is undefined. All right, 2 lines to the right are parallel. What do we know about parallel lines? They never what? They never intersect. Do you guys remember how we mark parallel lines? We're doing it all over the parallelograms and the rectangles and the squares. How do we mark parallel lines? Jack?
You put them 2 arrows.
Yeah, we're doing arrowheads in the same direction. You got it. So now what I want us to do is I want us to find the slope of AB and to find the slope of CD. So to find the slope of AB, we're going up 1, 2, 3, 4, 5, 6. So I'm going up 6, and then I'm running 1, 2 to the right. So it's a positive 6 over 2. Do we agree positive 6 over 2 is 3? So the slope of AB is 3. Now let's find the slope of CD. So to find the slope of CD, I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry, that's not 10. I went one up high, too high. 9. So my rise is 9, positive 9, and my run is a positive 3. So here my slope is 9 over 3. Well, what's 9 over 3? 3. Do they have the same slope? Yes. Do you think that's a coincidence? No, this is not a coincidence. Parallel lines will always have the same slope. What do you notice about the slopes of these lines? They are the same. Two lines are parallel if they never intersect. The slopes of these lines are the same. Always. Parallel lines will always have the same slope. Okay, we ready for the next one? Okay. The lines to the right are perpendicular. Who remembers that vocabulary word? What do perpendicular lines make? Jack? Right angles, exactly. So when they say these two lines are perpendicular, where they intersect is going to make four right angles. And I want you guys right now to find the slope of GH and to find the slope of, EF and GH. So right now on your own, you're going to find the slope of EF and you're going to find the slope of GH. Can somebody tell me the slope they got for EF? What's the slope you got for EF? Noah, what'd you get for the slope of EF? 5 over what? 5 over 2. I didn't do it. Did you guys all get the same thing? Yeah, awesome. All right, what did we get for the slope of GH? What's the slope of GH? Jonah, what'd you get for the slope of GH? That is correct. Okay, so now I want us to compare these two slopes. Do you agree this was 5 over 2 and this is 2 over 5, meaning the fraction was flipped? Does anybody know what you call when a fraction is flipped? Starts with an R? The reciprocal. When a fraction is flipped, it's called the reciprocal. 5 over 2 and 2 over 5 are reciprocals. One is positive and one is negative. What you call this is opposite reciprocals. What do you notice about the slopes of these lines? They are opposite reciprocals. Let's give some examples of opposite reciprocals. What would be the opposite reciprocal of 3/7? Can somebody tell me the opposite reciprocal of 3/7? You got it, -7 over 3. What about the opposite reciprocal of 2? What's the opposite reciprocal of a positive 2? This one's a little bit trickier. Leilani? Perfect, because really that 2 can have a denominator of 1, so it would be a -1/2. Do we all understand how to make opposite reciprocals? Okay, so this is not a coincidence. Anytime lines are perpendicular, their slopes are going to be opposite reciprocals. So two lines are perpendicular if they intersect at right angles. The slopes of these lines are opposite reciprocals. Sure. All right, this is going to be our last problem. Once we do 7A, B, and C, we don't have to know how to do numbers 8 or 9. Okay, points 4, 1, and 9, -7 are on the line. What is the slope of line M? All right, so now this time I'm not giving you a diagram. I'm giving you the 2 points. So we're going to have 4, 1, 9, -7. So this is going to be x1, y1, x2, y2. And so the slope is going to be y2 minus y1 over x2 minus x1. So I have -7 for y2 and 1 for y1. So we're going to have -7 minus 1. And then we're going to have 9 for x2 and 4 for x1. So then we're going to have 9 minus 4. I'm going to do my keep, change. So that's a -8 over 5. So now this is the slope of line M. What will be the slope of a line parallel to line M? We have to remember, parallel lines, what's the relationship between their slopes? They are the same. All right, so what is the slope of line M? Parallel to line M? -8 over 5. Okay, what is the slope of the line perpendicular to line M? So now we have to think. Parallel lines have the same slopes. Perpendicular lines, Jack, have what? Opposite what? Flip. What is that called with an R? Opposite reciprocal slopes. Opposite reciprocal slopes. So Jack, how am I going to make an opposite reciprocal of -8 over 5? So it's going to be a positive 5 over 8 because that one's negative, this one has to be positive, and then you just flip it. Okay, we don't need to do those two problems. All right, we are done here.